Howdy, everybody. Hope you're having an amazing time whenever you are. We're here for day 22 of Advent to Code. I'm actually really excited. I think I found a decent solution, but I don't have a lot of time today, so I thought I would just can I solve the problem? And I got it solved. But I'm really curious about what optimizations other people are doing. So if you have some optimizations, I would love to see how you optimize yours to get yours to complete faster. Um, anyway, with that in mind, today's day is not, there's not a lot of magic to it, I guess, if that makes sense. It's a lot of it's just kind of like going through the steps, I guess, is the way to think about it. Um, Unless you found some cool optimization. So we'll look through some solutions, but I'd also love to see yours. Okay. So let's just dig into it. We're doing Monkey Market, and the idea is apparently monkeys have an exchange market for bananas, and uh they stole your device, and so you need to get it back, right? And the monkey's willing to trade for it, but only exchange for an absurd amount of bananas. Which, now that I think about it, is a little funny because the number's not actually that large, but well, maybe to a monkey it is. So the idea is you're going to use this exchange market to like find these best prices. The idea is like, how can I maximize the number of bananas I can get uh, from this market, is the way to think about it at a high level. And that's what both part one and part two kind of step you through that whole process. And I should say, like, these days are like not uncommon in Advent of Code, or these type of puzzles, where like the idea is you're like building through a process to between part one and part two to get to like the final solution, is like, what is the maximum number of things I can do it. And so like part one is kind of like to help you get there, and then part two is like to finish it off, if that makes sense. So how does this all work? Basically, they say the market exchange is based on like a pseudo random number generator, and then it gives you the directions for the pseudo random number generator, which is right here. And the way it works is, if you have a secret number, you take that number, multiply it by 64, then you mix and prune. Then you take the number and divide by 32, and then mix and prune. And then you take the number again and multiply by 2048, and then you mix and prune. So the idea is you're doing these steps multiple times. Multiply by 64, divide by 32, and multiply by 284. And in between each of those, you do these mix and prune instructions. And the way that it describes the mix is you're just doing a bitwise XOR. Okay, I clicked on the link. Hopefully, though, you're probably familiar with an XOR. If not, feel free to check it out. Essentially, maybe I should just say, an XOR is like a bitwise operation where the way that you get the value is by the differences. So if they're different, it's a 1. If they're the same, it's a 0. So like, see, did I say that? I may have said that the wrong way. So because these are both a 1, this is a 0. Did I say that right? If they're the same, they're a 0. If they're different, they're a 1. Okay. So if they're both 1, you get a 0. If they're both 0, you get a 0. But if they're different, one's a 1 and one's a 0, they both get 1s. This is actually used a lot in like cryptography and stuff like that. Just because it's a great way of kind of like mixing things up, but also reversing it. That's the key thing, is like, if you know like the quote unquote secret, it's easy to take something that's jumbled up and reverse it. So I actually think there may be some optimizations in here. I'll be interested to see if like this process, notably you're using 64, 32, and 2084, which are like binary friendly. I don't know. I don't know if that's the right way to say it, but there may be some quicker way to calculate this. But I didn't try it. I literally just gave the instructions. So you can see here. Here's my function to do it. Multiply by 64, XOR it with itself, and then do it modulus this big number, right? And so you multiply by 64 and do that, divide by 32 and do that, and then multiply by 284 and do that, and that gets you your answer. And so what does part 1 say? Well, I'm going to give you a secret. I'm going to give you a secret, and I'm going to give you a secret number, and I want you to find the 2000th secret number in that sequence, right? So because they like loop in on each other, you use the previous secret to get the next secret. The idea is, can you do that over 2,000 times? And then it says, like, so for 1 it's this, for 10 it's this, for 100 it's this, and for 2024 it's this, right? So the answer to part 1 is, can you just sum up all the 2,000 secret numbers for your puzzle input? And there's a lot of them. I actually don't remember how many there are. 2,244 for my input. So there are a lot of them, but really what you're just doing is like, can you get me the nth sequence? And fold is a fun way to do this, because if you think about, if your initial value is the secret and you just store the secret in your accumulator, you always know that like your next value is just the next of the accumulator. And so this is how I get the nth secret for anything, right? Is I say, just call next on the accumulator, which in this case happens to be the secret, over and over again. And I just do that for over 0 to n. And that gets me. And so that's really all there is to part 1, right? Is you just say, hey, for each of the lines, I used a filter map here. As I was doing this, I'm like, oh, do I want to unwrap here? And I don't know why, but for some reason I'm like anti-unwrap. Maybe I should just get over it because we're doing puzzles. But I use a filter map and an okay. Again, if any of these didn't parse, this would actually give you, well, it would be invalid input, and so presumably that doesn't be the case. But there's really no difference between, like, I'm trading filter map and okay for map and unwrap. Like, these are essentially doing the same things. So I have no idea why I did do it one way or the other. I'm not usually a fan of unwrap, though, I guess is what I'm saying with all of this. Maybe you guys can help me seek therapy on getting over my unwrap issues, but there you go. This is how I did it. So basically I just take each of the lines, turn it into its integer. Notably, I do an I size here because later we do some subtraction and stuff, so I used it as an I size. You get negative numbers is what it is. And then I just say, for each of them, give me the nth secret, where n is 2,000, right? I could change these to make this more readable. So we could change this from n to secret. I tend to use, like, when I'm just typing out and doing things, like N, I, K, V, those type of things. But I do find it's sometimes more readable to do this, so there we go. But that's just the answer to part 1, so. Excuse me, nothing really crazy for part 1. It's just like, can you do this math, and can you do it n times? And it actually runs really fast. As I was doing it, I was like, oh, am I going to need to like cache this value or something? I don't think you will. Like, it may not help you just because these operations are so fast. The compiler will probably like inline this whole thing. Like, you could do this all in one line type thing. You can't really do it in one line because you do this step, then you do this step, and then you do this. But you could easily inline this, and so you're not doing a function call, and now it happens really quick, right? So that's it. Part 2 adds some complexity to it. And I'm going to try and describe it. Hopefully it will make sense to you, but let's just go through it and see if we can get to it. So now that you can calculate the nth secret, there's like these weird, they want you to use that list of secret numbers to try and find the right time in the sequence to buy bananas such that you can get the most bananas. And so how well, oh, so you're trading, by the way, you're trading bananas for hiding spaces out in the thing. That's kind of irrelevant to the puzzle, but the idea is now you're going to have this sequence of numbers that looks like this, and you're going to want to find the right time within this sequence to buy it. And so, like, how do you do that? Well, first off, it says the price that you would buy it is just the last value of each of the sequences. So if this is your sequence, the last value here is a 0. This is a 6, 5, 4, 4, 6, 4, 4, 2, 4. This is a simple modulus operator, right? If you just say, hey, get me the remainder of dividing by 10, it will get you that number, right? So that's all it's saying. Is the first part is like, what is the price? So these are all the prices. And then it says, you actually can't buy it yourself. You have to get this monkey to help you, but you can't really converse very well with the monkey. And the only way that you can converse, the only real way that you can converse with the monkey is you can give him a list of 4 numbers that tells him when to buy. And those 4 numbers are equal to the differences in the prices. So what does that mean? If these are the prices, the difference between these two prices is -3, right? And then the difference between these two is 6. The difference between these two is -1. Am I doing those right? I think this one's -6, -1. Where is it? Here it is. So the difference between, so here's the original number, here's the prices, and here's the differences, right? So the difference between these two, 0 minus 3 is -3, 6 minus 0 is 6, 5 minus 6 is -1. These are the differences. And so what the problem is asking is, you can give the monkey 4 numbers that are these differences, right? So it and whenever he sees those 4 differences, that's when he's going to buy it. So if you gave him the number 1102 or -1 -102, he would see -1 -102 here, and then he would buy this 6 right here, right? So just as another example, here's the numbers, here's the prices, here's the differences. If you gave him the number negative, what is a weird one, 0 2 -2 0, he would find it the sequence right here, and then he would buy right here. And just to clarify, because I've had bad days reading, I went through and read this very clearly. He can only buy once per person, and you can only give him one sequence. So the way to think about that is now is you're going to have like 2,000 initial secret numbers, and each of those 2,000 are going to produce 2,000 secret numbers on their own. And then those 2,000 secret numbers are going to have prices, and those prices, you're going to want to find the differences between them. And so you're going to have, around 2,000 prices and 2,000 differences. And it's actually 2,000 minus 1 differences is what you're going to have for each secret number in your input. And you're going to want to find the 4 sequence of numbers that's going to maximize the number that you can buy over all of the entire input. Okay. I don't think that's like too hard to grok. You just have, at least for me, I just had to read it a few times before I understood what was happening. And I actually broke it down. So you can actually see my puzzle solution is like relatively small. I got it down to like 80 lines of code. And like, here's where I'm doing the bulk of part 2's work. There's actually not a lot to think about doing it here. But what I basically did to solve the problem is I said, oh, okay, well, let's first just see if I can find the prices and then the differences. And then now can I do the windows to find those differences? And what do I do with those windows of differences, right? So it was very much a building process. And so let me just walk what that is, right? So for each number, right, for each one, you're going to have like a series of secrets that are going to come out of it, right? So so on and so forth, right? You're going to have this big pile of secrets. And each of those are so you're going to have the secrets. And then you're going to have each of those are going to turn into prices, right? So you're going to have P P plus 1 or whatever, right? It's actually, I should probably describe it more like this, right? P. Should we just start this thing over? Regrets. Regrets, I have a few. Where's the eraser here? Okay, so each secret is going to give you the following. You're going to get a set of secrets. I apologize for my writing, right? So S1, S2, S3, and so on and so forth. And then each of those secrets are going to have a set of prices, right? They're going to be turned into prices. I keep saying set. It's a list of prices, right? So you're going to have these secrets can be turned into prices, right? And you just do that, so on and so forth. And then from there, you're going to be able to get some differences, right? And the difference is this minus this. So D1 is going to be the difference of these two values. And D2 is going to be the difference of these two values, right? And so on and so forth. And you'll just keep doing that, right? And now that you have this differences, you want to find some set of 4 of them. So you're going to create some windows of size 4, and you want to match those to the prices, right? So you're going to have a window 1 that is like these first 4 values, and its price is going to be P4 right here, right? So this price is associated to this window, and it's going to translate to that thing. And so you're going to have a bunch of windows and a bunch of prices, and the goal is to say, how can I maximize that? Well, you can maximize it over 1 by just iterating over the windows and find the largest one. But we have to maximize it over, for all of the secrets. We have to do this like algorithm, right? So my intuition was, or my thinking was, well, what if I just collect these windows into a map where I have the window and the price, and so now I have all of the windows and their price in this little map. The only gotcha is that I had to that as I was reading, I had to like make sure I had right was, the monkey will only buy it the first time. It would wait until the first time it sees that sequence and then immediately sell your hiding spot information at that current price, winning you, in this case, 6 bananas, the example it gave you. So it's only going to do it once per window, right? So you imagine like you have some window and you're going to do it for all the secrets. That window is only helpful if it's the first one in the list, right? So you can essentially ignore any additional windows after you found the first one. The way to think about it is like you're uniquifying it and just storing the first price that you find. Okay. But then what you can do is just, now that you have a map for each of the secrets right here, you can just combine those and sum up the prices per window and then just find the largest one, right? So if you, I don't know, if you call like join the equivalent of it, I mean, I used a fold. So the idea is you're going to fold all the windows into a single hash map that will give you a total price per window. And then the answer is just the max price. So the solution is, what is the max price? Right? Okay, so how does that look in code? Hopefully that I didn't confuse things by doing that. But you kind of just get there by reading these directions. And again, this is one of those days where it's just like you just kind of got to read through it. It's almost like you've received a user story if you're using Agile, or you've received like some kind of work. Here's the work you need to do. You just are kind of stepping through it, is at least is the way I felt about it. And you're slowly building up and trying to solve it until you get all the way there. So what does that look like? Again, we're going to collect all the prices. Notably, we want to include the price of the first secret. So that's why I use this once here. This is a cool thing. I had to Google for it because I was like, oh, well, I can find all of the prices after the secret, but I want to include the initial one in my iterator. And I think before I had done like a chain. So I'm like, oh, I can do a chain, but how do I chain a single value to the beginning? Normally when you do a chain, you have like one iterator and then a second iterator. And I was like, oh, I guess I could just do a vector and iter the single value. But I Googled it and found this once, which seems pretty cool. The idea is you just say, here's the initial value, and then chain that to the rest of them, and I'm going to collect them. And what are these prices? Basically, I just, again, I'm dividing by 10, excuse me, but this, the way this scan works is really cool too. You can think of it kind of like a fold, but instead of a fold, it's an actual iterator, so it continues to iterate over the folded the accumulator, right? So the idea here is you have some secret, you have some accumulator, you're going to call this function on the accumulator, but this state is mutable, meaning you can change it, and so you mutate the state, but you actually return the next value. And this one's useful in this case because if you think about what I want to do is I want to iterate over all the secrets and get their price, but the only way for me to get their price is to know what the previous secret was, right? And so that's where this accumulator comes in, this state right here. So how do you do that? You basically just say, hey, get me the next value of the state and update my state to that next value. So the next time I call this function, I get it. And then I just return the price, which is modulus 10, right? The remainder of dividing by 10. So this gives me all of my prices. Now I want to find the differences between the two. Well, how do I find the differences? I can just do windows of 2, right? So I take the prices, I break it up into windows of 2, and you just subtract the latter from the former and collect those up. So now I've got all of my prices, right? That's these parts right here. I've created all of my prices. I've created all of my diffs. And so now I can just do windows and map these. I just need to map these values, right? If I do these windows of 4, I can map these values, and this will give me my sequences. So what does that look like? We take our differences. We create windows of 4. I'm going to enumerate those windows. Why do I do that? Because I want to get to... I want to get the price, right? I need to get the prices value out of this first array. Again, I didn't think this through a lot. There may be a way to combine these all. I have not tried to do it yet. So if you can find a way to combine these, I would be interested. But the problem still runs relatively fast, so I don't, anyway. Again, let's go back to it. So for all my differences, I'm going to create windows of 4. I'm going to enumerate so I can go back to my price. And then I'm just going to fold on it, right? So I'm going to create a hash map. So this is my sequences right here. This is my accumulator. And then this is my I, like where am I in the I thing? And then this is my window. And so I'm just going to ask myself, have I already seen this window? I haven't figured out a cool way to do this. There's like, you can definitely do the entry one to get, to do an update or create. I haven't found a good way to do this. I tried to look around. But essentially what I'm doing is I'm saying, hey, Oh, do you know what? It probably will look cleaner if I just do like if not sequences dot contains key w dot to vec. That probably looks cleaner. I can probably let key equals that. Okay, that probably feels more readable. The idea is, my initial thinking was oh, I'm going to update values, but then that's when the monkey thing came in, is like, oh, you only want the first. And so that's when I used that, like I tried to switch over to that occupied. That was my thinking, at least there. Probably not optimal, but this feels better. I can just say, hey, if I haven't seen the key before, I'm going to do an insert, right? The reason I went that way is because normally what you do is like, hey, if I haven't seen it, do an insert, else do an update to it. And that's where you can use the entry, or at least I've found the best way to use the like cleanest looking way is to use the entry of it, to get the entry and then do that, or default value, and then add the value that you want. But this definitely looks cleaner. So again, just to highlight, I went down in the weeds there. I'm going to grab windows. I'm going to enumerate so I can get the price. And then I'm going to just create a hash map by folding and say, hey, if I haven't seen a key, insert that key with that price. I do +4 because remember, the windows are a width 4, and and the price you want to sell it at is at this 4th price right here, the last price. That's when you're telling the monkey to buy. Have I been saying sell? You're telling the monkey to buy. You're buying at that. You're buying that number of bananas because you're trying to maximize the price. So there you go. That's part 2. Oh, well, I should say, what do you do once you have this? Now you have each of those windows, or you have a map of the windows to their prices. Well, now you just you can go through all of them and flatten them and then fold them again. And this time you actually are, here's where I did the entry or insert, right? This time you want to know the total sum, right? So if you're going like this one, this single one will contain the first window and its price, but now you kind of want to know, like, what is the sum price of, all windows, right? How can you find all windows? And so that's, and what is the maximum of those, right? So that's what we do here, is we say, I put an unwrap, I'm masochistic or whatever. Okay, so basically what we're doing here is we just say, hey, go through all of these sequences and flatten them, and then we're going to create a new map where we sum up all the values. And so now we just need to find the one with the highest value, right? It doesn't actually, it doesn't ask you what the right sequence is. It just asks you what the maximum number of bananas is. So I just returned the max right here. Should I try and fix this so I don't feel bad about myself? I probably let the AI go too far without inspecting what it would do. I mean, this would never be the case, so I don't know why I do this. Maybe you can figure it out. Why is it that I hate unwrap so much? But there you go. That's for part 2, right? Again, I'm just going to gather all those sequences, the best value or the first value of the window for all the windows in that thing. I'm going to fold it into a thing where I sum up all the values, and then the one that's the highest is part 2. Do I still get the right answer? Yes. And you can see it takes some time, but it happens in under a second. Like, the total runtime is this. So, like, my thinking is, like, how do you optimize it? And I actually don't know. Again, I'm short on time today. but I kind of want to see and look and see. So that's what we're going to do now. And I would love to see your solutions, right? Again, before we do this, I kind of feel like this day was just a can you follow the instructions, because it didn't feel like it was so complex that it was required like some magical thinking or something. I don't know. That's my mind. Buy an absurd number of bananas. Look inside 23. Yeah, there you go. I mean, mine was small. It was, although 2,000 bananas is quite a bit for a monkey. Secret number. Oh, yeah. If you got that wrong, math problems. Debugging with pecans. Oh, this is from the previous day. Okay. Day 22. 1, 2. Are these the same numbers when you do like the modulus stuff? Do they, maybe they produce the same one? Actually read the problem properly for once, or sort through all 16 million prizes of each buyer. Me iterations. Oh no. This one I did, I don't know if you've seen my previous videos, but I trolled myself on some of the problems. And so I really read through this and was really careful. Oh no, I stopped with AOC like every year around this time. I stopped for 2 reasons. I have too many other things to do with family and holidays. It gets too complicated, so I'll probably sometime. There have been days where I've had to skip and I had to catch up and stuff like that. And in previous years before I started doing these videos, sometimes it would take me like a couple months to get to all of them. Yeah. Yeah, I think it's okay to not finish it in the 25 days. It's not like you've suddenly failed if you don't do it. Um, I don't know about getting upvotes or hearts when the monkey sees a good deal, but it's not the right sequence. Oh, poor monkey. That is true. You're trying to convince this monkey to maximize your bananas. Yes, I know these are chimps, not monkeys. Okay. Is that how we're going? Okay. They probably had to make this thing just so they don't get a bunch of comments about, well, actually. Oh, this is cool. Like kind of tracking it change as you go through the thing. That's kind of fun. Yeah, if you think about it, as you're going up, like you don't actually know what the right sequence is until you've gone through all of them, unless I'm missing something. Again, I didn't try to optimize it, so I didn't check very far because it all finished in about a second. So I just kind of tried to clean up my code a little bit and get to it. Um, quick tutorial saw part 2 in under 0 point. Because it's Sunday and Allison. Oh, this is part 2. Or sorry, day 21. How fast did my day 21 go? I don't actually remember. I mean, really fast, right? So, okay. I don't know that I have. Oh, we did find some optimizations that we could do, right? Is you could minimize the number of branches because you'd pick better paths. Okay. Hey, they both work. I don't think this problem lives or dies by how quickly you do this operation. So you're good. You're good. You're good. I mean, this is true, probably. I'm almost sure it is because you're like turning it to a string and then back to an int. But I don't think that's going to kill your algorithm. I'm kind of tempted to see how much it changes it. How is he doing it? Kind of like this. I mean, this is not faster, but let's just try it. Yeah, I mean, it still solves in under a second. So, again, it is definitely, if you know the trick of the remainder, it saves you a lot of time. But I don't think it's going to make or break the algorithm. They're saying they want bananas for that. You can buy bananas for good hiding spots in the monkey exchange market. Yeah. Some of the things you do are absurd, but you know what? I don't remember this day. I think I've solved most of day 2022. Me when a monkey tells me their starting secret number. You got to pump those numbers up. Those are rookie numbers. Okay. Monkey. Oh, can you how much can you parallelize this? And how much does it help you? We can try it really quick. Today was an easy enough day that I don't feel too bad about trying these things. Which one do you what do you want to parallelize? Is it this? Oh, you're gonna fold, so you're gonna have to reduce. I need to add the thing in there. Wait, it figured it out. Okay. It's about as third as fast, a third of the time. So what am I doing is can you parallelize this process, right? And you can definitely parallelize the upfront work, but eventually you're going to have to bring it all together, right? So how does that work? Basically, you say, "Oh, I want to parallelize each of the lines." And for each of the lines, I'm going to call filter map and then flat map to get the sequences, and then I'm going to fold those sequences into um their counts. But this is actually happening. Do I actually need to fold? I don't. I actually don't need to fold, huh? I was thinking you had to fold to get the values, but then you sum them up over the thing. I think you just do this. What is it not happy about? Is it that it doesn't know what type it is? I don't want to do all this stuff. How do I discard? Discard. Go back. Maybe I do need to fold then. Why do I need to fold and then reduce? So, like, this is going to produce this. Oh. I'm not thinking about this in a parallel way. This fold is going to be called multiple times um, for a group of these flat mapped values. Yeah. You have to think about this in a parallel way, like if you've ever used like MongoDB or any of the MapReduce style things where you're doing like aggregations. Um, I'm going to filter and then flat map, and this is going to produce a whole bunch of hash maps, and it's going to fold some number of those hash maps, right? And I'm going to sum up those values. And then I'm going to, so this is like maybe, so that let's say there's a million here. It's going to do this for each 1,000 of them. And then I'm going to reduce the, whatever, the 1,000 that came out of it using this one. So that's why I have to do it that way. So there you go. And then that finishes a third of the time, I presume. Still get the same number. Yeah. Okay, so maybe I can help clarify this a little bit. This is going to happen on chunks of the flat map above. Unless I'm missing something, I think this is the way it works, right? So I could be wrong. Let me know. But I think that's the way it works. And yeah, then that nets you, that's a third of the time. Okay, that's cool. You'll need get it back. Oh, did someone find a typo? You'll need literally unsolvable. Trade career insanity for groceries. Okay. Yeah. I mean, again, I think this was a one that maybe it's not clear to you like how to just I don't know. Maybe it's not clear how you go from like the I don't it like literally tells you what to do, right? It literally says, here's your secret numbers, create prices, create differences, and then find sequences of 4 that maximize. Maybe that's the part that can be a little difficult, is saying like find sequences of 4 that you can maximize. And so like you had to think about that for a second. But the way to think about it is, oh, I'm going to I'm going to find all of the sequences here and keep track of them and their values, and then I'm going to sum up, and then I'm going to like merge those values with all the other ones. So I guess that part could be a little confusing. That part is not like literally spelled out in the thing. Okay, so I can see that. Up until this point, it's literally just, can you follow instructions? And then yeah, you do have to say, oh, how do I go from here to here? Okay. It didn't seem that hard to me, but I can see how that would be hard now. And so I just missed that. Some things are obvious to the people who it's obvious to. I mean, I had days before, go back to my videos, where the obvious was literally in the text and I missed it. Optimal monkey policy. I was surprised to see the was as small as it was. On average, we got less than 1 banana per monkey. Oh, that's a good point. What that means is like the best solution was where like there were some monkeys you didn't actually buy from. Like did I said before there was like 2200 monkeys and then we only bought 2000 bananas. Okay, so I mean this person is definitely doing some crazy work to get to like what is the optimal. And like what they're saying is, and this is kind of interesting to think about, is as opposed to just saying I'm going to give you 4 differences and you figure out, and then you go buy it all those, how do you maximize that? Like, can you do some actually like stock market analysis stuff and say, hey, here's the right times to buy for each of them, or and find an even better way to do it? So what's the non-brute force trick? What's the analytical way to solve it? Can you derive the correct sequence from discovering something about periodicity? Collected all sequences that exist and their first price per buyer, then sum the results. It takes 20 seconds. I mean, 20 seconds really depends on what language you're doing it in. I guess I didn't pay attention. But I think this is the generalized solution. I suppose if you had the entire circular list of 16 million numbers on hand, you could program something to solve all of them at once, but I don't think anyone has enough RAM to do that, I suppose. Oh, maybe I did misread how they were doing it. They're literally checking every one. Like the brute force is to like just say, what's the highest price if I do this number or this number or this number, and you like check all 4. Yikes. Yeah, that is not better. But they said it only runs in 20 seconds. That's still really fast. Okay, let's do one really quick, or peruse through the solutions, and then we'll be done. Uh, These are really fast. I actually don't know if you need to cache them. I mean, I suppose if you're reusing it throughout the algorithm and you're not, like, I stored mine in a list, so I always had them. I wonder how much it nets to cache. I could cache it really quick. Again, I don't use it a lot, so I don't know. It makes it worse? Well, okay. Why would it make it worse? I exactly know. So this cache is wrapping like a memo in it, right? And so it's keeping track of values and setting them. What that's saying is it's literally faster just to recalculate it than to go consult the cache. Yeah, so what is that saying? It's literally faster to recalculate this number than to go consult the cache. Which probably makes sense because for large caches, even though the operation to find the value in the cache can be relatively short, it's probably not shorter than doing this math right here. So yeah, caching probably doesn't help you, save you. It makes it worse. That's hilarious. I guess I don't want to read too far into it. I'm having a problem grokking it. Maybe it's just my own tiredness, but it feels like what they're doing is closely similar to what I'm doing. Takes 8 to send. Okay. For some reason, I decided to try to go for speed on CPython. Masking during the next secret computation is slightly faster than doing it after. And also, we get to not mat. Yo, this is some crazy to read the text. A bunch of integers. Oh, is he doing this so that he can get like the... No, you wouldn't do that yet. What is happening here? For match A in compile... He's just getting like the integer values? I have a harder time reading it, but I it looks like they're doing the same thing. These like bitwise operations seem to... He's saying they make it, or they're saying they make it faster. Like I said before, the bitwise operators are like reversible and exchangeable. Oh, I bet you what they're doing is they're just saying like do this and then do the bitwise here, because like these three operations are like interchangeable, I think is what they're saying, right? Yeah, especially because when you're like dividing by 32 or 64, like you can see is you just, or you multiply by 64, it's this, divide by 32, it's this, multiply by 2048, it's this. So you can then do these operators after the fact because they have like, they're like, because they're all bit operations, you can kind of do them all at the same time. Okay, one more. Let's see if we can find someone in Rust. Easy enough. 2,000 iterations of the secret rotation. Add up the results. For each monkey, look at the delta set in turn. If we haven't seen it before, add it to the total. Okay, let's see what they got. Get input. Oh, that's a good point. I could have done this at the beginning. That's a nice, because I do this for the lines. So I could say, put it right here, like let secrets equal input dot lines dot filter map dot collect oh, I need to do this. Where's the borrowed? Oh, I do an into. Okay, I can just do this one as an iter as well, and then do this right here. Okay. Why is that consistently slower for part 2? And it's slightly slower for part 1. I mean, I can see part 1 being slightly slower right here because you're doing the you're like creating a vector now, but it feels like part 2 should be faster because you already have the vector and you've already done the parse. It's actually faster to do it this way. Oh. Oh, maybe there's just a lot of variance right here because of maybe the number of times you fold and then reduce. That's probably it. We were just getting unlucky. Okay, let's look at the actual code. Okay, this is another way to do it. Yeah, like I use the fold here, but you could like have the secret and then you just for each of these call it again. And then you sum them up. Yeah, this is perfectly fine. I mean, that's essentially what I did. I just did mine in a more functional way, right? Using like flat map and fold. Oh no, that's part 2. I just did map and sum. So this end secret is actually just the fold. So I could potentially done it inline right here as well. And then it would look more akin to this, but doing it functionally as opposed to in a for loop. I actually am not averse to like some people saying, oh, I liked a more iterative approach, or other people saying, oh, I like the more functional approaches. It really depends on how you are. I just happen to like the functional, especially for Rust. The ones that will do functional things, it feels like it's easier for me to read because you're like stepping through what you want for them to do. But to each their own. They all have different ways of thinking about it, right? Part 2, for secret and secrets. Okay, yeah. So they keep a big window of like all the all of the totals, and then you're going to create your own scene list and basically do what I did. Yeah. Yep. Okay. Oh, modifying the value inline. That's an interesting thing. This would be one that's interesting to look and see if it's worth doing this, like with, because like if you think about what the compiler ends up doing, is this like it's doing these operations and then storing it in its own thing, its own register, instead of using like multiple registers. It's possible that it compiles down to the same thing too, right? And then just the difference is like where do you put them. So anyway, there you go. There is day 22 in the bag. Hope you had fun doing it. And again, if you're watching this in the future because you just got done with your 22 and you wanted to see how I did mine, or maybe you're looking for help on how to solve your day 22, that's totally fine too. It's not a race. I just like to do it on the same day. It's kind of a fun way for me to be like, oh, I'm puzzling or whatever. But just have fun solving these, and if you're having fun, you're part of the spirit of Advent to Code. So there you go. Have a great day. We'll talk to you all tomorrow.